Morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Is everybody doing good? All right, warm-up number 22 is on the screen. Let's get started, please. Yesterday we started with each four. Hopefully you remember what to do. I'll give you guys some time. Copy and go. At the end, after the warm-up, make sure you get at least 3 graph papers. We're going to need graph paper today. All right, should be just about done, at least with number 3. So today I was thinking I randomly selected a letter, so I'm going to pick people that their name starts with the letter D. Letter D. So you know who you are. And just FYI, this session is being recorded. FYI. So we got Danielle in the back. Let's go, Danielle. Daniela over there on the side. And Dayami over here in the front. They're going to be helping me out today. Let's go. But before that, I'm going to go over number 1 one more time. Here it goes. Let me make some space here. There it goes. So, number 1. First things first, we need to rewrite this. Is that correct? And I said we need to have an exponent with a fraction and then 1 on the numerator. So I would rewrite this to 4 to the 1/2 exponent. And since I moved the 3 out of the way, the 3 I put it right next to that. Right next to that. Hands if you did that by yourself, some of you, okay? From there, we said now we can actually do this part by itself. We know that the 1/2 becomes a what, everyone? 1/2 becomes a square root. The 1/2 exponent becomes square root. Square root. Now I'm going to bring down the 4. From there, I put a parentheses. Why a parentheses, Mr. Q? Because here we have a times right here, and the exponent is 3. Therefore, what is square root of 4, everyone? 2. Bring down the exponent of 3. So this becomes 2 times 2 times 2, which is 8. Let's go to part B. Part B, we have a square root on the denominator. Can we have a square root on the denominator? No. So that means we multiply top and bottom times that square root. So square root 3, square root 3. From there, we end up with, what's in the numerator? 5 square root 3. And what is 3 times 3? Square root of 9. And last but not least, we simplify the denominator. The numerator stays the same, 5 square root 3. And what is square root of 9? 3. And that's how we get rid of the denominator. Let's go to number 1C. For 1C, we need 2 factors, 2 numbers. One of them has to be a perfect square. So quick review. What are my perfect squared numbers? What is 1 times 1? 1. 2 times 2? 4. 3 times 3? 9. 4 times 4? 16. 5 times 5? 25. So which of those times another number gives me 2? Yeah. 9 and 2. So we write this as square root of 9 times 2. So why do we need one of them a perfect square? Because now we can take the square root of 9. What is square root of 9, people? 3. And now we cancel that one from here because it became 3. And what do we have left inside of the square root? 2. So we end up with square root of 2. You good, Renzo? Yeah? All right. Let's go to number 2. Number 2. So for this one, let me get these out of the way. For this one, remember, it needs to be in this form. Y equals mx plus b. Is that correct? So, help me with the top one to graph the top one in blue. Look at this one. This one is already, it looks like this, doesn't it? So, where do I start? Tell your neighbor, where do I start to graph this equation? Where do I start to graph that equation? Share with your neighbor. Then we're going to have Danielle give us the starting points. Where do we start? Tell your neighbor, please. All right, good conversations. All right, Danielle, where do we start? -2. That is correct. So let's go to -2. And then we need a slope. What is the slope next to the x? 3, and fraction form is 3 over 1. That means 3 steps up, 1 to the right. Plot your point. Do it again. 1, 2, 3. 1 to the right. Plot your point. Graph your line. Arrows at the end. All right, next. Is this one in y form? No, the y is not by itself. So tell your neighbor what to do, and then Daniela is going to guide us through that one. What do I do to leave y by itself on that one? What do I do to leave y by itself? Tell your neighbor, please. What do I do to leave y by itself? Daniela, what do I do? Subtract 2x to each side, and then we end up with y equals -2x plus 3. Hands, have you got that? That is correct. And to graph it, look at it. Where do I start? Tell your neighbor, where do I start? And then Dayami's going to guide us through it. Where do we start for that one? Where do we start? The top one we started at -2, so this one we start at what, Dayami? At +3. So we go to +3. From there, we need a slope. What is my slope? It's a -2. -2 over 1. That means 2 steps down and 1 to the right. So 1, 2, 1 to the right, 1, 2, 1 to the right, 1, 2, 1 to the right. Graph your line. There it is. Arrows at the end. And then I want you to point to that and write solution. What is my solution? The solution is 1, 1. Pretty good, pretty good. All right. Go to number 3. Number 3, we are experts at that one. Show your neighbor what you got. Then Kiana is going to get us started with that one. Number 3, show your neighbor what you do for number 3. All right, good conversation. Kiana, get us started. What do I do first? Change it into y. So y equals 3 times x squared plus 2. Pass them one. Me? All right, pass it back to Kiana. What do we do next, Kiana? Subtract 2, subtract 2. We end up with y minus 2 equals 3x squared. All right, tell your neighbor what to do next. Then Kiana's going to pass someone. Kiana, pass someone. Who? Autumn. Autumn, what do I do next, Autumn? I need to leave x by itself. Close. The 3 is multiplying, so what is the inverse? Divide by 3 both sides. We're left with y minus 2 over 3 equals x squared. Tell your neighbor what cancels a square. Tell your neighbor what cancels a squared, and Autumn's going to pass someone. What cancels a squared? Autumn, pass someone. Jaime? Square root to both sides. So this cancels that. We're left with x. And then on this side, square root of y minus 2 over 3. Is that the inverse? No. What do we do to the inverse, everyone? Yeah, exchange the variable. So I'm going to go over here. So we got square root of x minus 2 over 3 equals y. This is my inverse. However, do we leave it in y form? No. Square root of x minus 2 over 3 equals f inverse x. Are we doing good? Yes, Mr. Q, give us a pop fountain. All right, good. All right, let's go to number 4. I'm just going like, no. Let's go to number 4. All right, let's do number 4 together. It says solve. Here we go. So first things first, we need to rewrite this one. The exponent is 1/2. Tell your neighbor what 1/2 exponent means. What does that mean? Yeah, it becomes what? Square root. This becomes square root. So we got x minus 5 inside the square root equal to 5. Next, we need to cancel the square root. What cancels the square root? Okay, let me go back to the previous one. What canceled a squared? A square root. So therefore, what cancels a square root? The square. Square here and square there. This cancels that. We're left with x minus 5 equals 25, and the rest is history. Plus 5 plus 5, x equals 30. Pretty good, yeah? Yes, Mr. Q. Copy the agenda, please. Agenda warm-up number 22 done. Transformation of functions. And hopefully for tonight, thank you. One problem, 3 transformations. 3 transformations. Also, do me a favor, go to Canvas, turn in your home plate from last night. You needed to write 4 equations and the transformations. Yes. Yes, that's fine. So I'll give you some time for that. Set up a Cornell notes. Also, you will need, like I said, at least 2 or 3 graph papers. Make sure you grab them. Today we're going into bigger functions, so grab some graph paper. All right, write this code down. 2 axes of home plate, XV2KU. Write that down, please. XV2KU. XV2KU. That's going to give you access to the home play on the slides in there. And once again, last night's home play was this one. 2 problems. Each problem had 2 equations that you needed to write and the transformations. Tonight's home play is only one problem, 3 transformations. Yeah. XV2KU. That's the axis to the home plate. And that's why I'm only giving you one itty-bitty problem. But today we're introducing a new parameter. Let's go. Go, Julian. All right, here we go. I can transform a function using different parameters. I can transform a function using different parameters. Oh, before I continue, send me your warm-up. Give me. All right, here we go. I can transform a function using different parameters. By now we know what a function looks like and what they are, right? I've been asking you to give me an example and an example almost on a daily basis, so I'm not going to ask you to do that again. You already have those notes. However, we are moving on with parameters. We've been working with H and K. K moves it up if it's positive or down if it's negative. H moves it to the right if we substitute a positive value, or moves it to the left if it's a negative value. So far so good, yes? Yes, Mr. Q. So today we're moving on. So get your graph paper in front of you, but this time we're going to use the big graph. Turn to the big side graph. And I want you to write this at the top or on the side if it fits, but I need 3 tables. Look up. This one, this green one, and this red one. So you need 3 tables and write example super duper Q. I'm going to give you some time. Let me send that to your screen. All right. So by now you should be done with your setup. Everybody with me? So let's start with f of x. I'm going to use black for the sake of time. Here it goes. So to start with f of x, this is a quadratic. So what do we do with each of these numbers, x values? We square them, yes? So what is negative 3 squared? Negative 3 times negative 3 is 9. Write that in there, please. We're no longer going to do the substitution. By now, it should be automatic in here. Next one. What is negative 2 squared? Positive 4. What is negative 1 squared? 1. 0 squared. 1 squared. 2 squared. 3 squared. Let's plot those points. Negative 3, 9. Negative 2, 4. negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. We're going to label this one f of x, f of x. All right. All right, before I continue with the next one, let me show you an observation. Writing utensils down, look up to the screen. Writing utensils down, look up to the screen. Here it goes. In the past stage, we've been using what parameters? K, that moves it up and down. It's at the end of the function. We've been using H, that's inside of the parentheses with X. Is that correct? However, look at this observation. Look up, please. Where do we have a number now? In the front. It's not inside, and it's not at the end. This is different. How different, Mr. Q? Well, let me show you. Look up, please. So, what did we do to get f of x? We squared it, didn't we? Okay. So that means for this one, we have f of x squared, but it says the 3 in the front. What does that mean, Mr. Q? That means that it's multiplying f of x squared. So here it goes. Look up. When x was negative 3, what was f of x squared? Everyone? 9. But we have a 3 in front of it, so it would be what? 3 times 9, which is 27. Write that in there, please. 3 times 9. The next one. When x was negative 2, what was f of x squared? It was 4. So what would we write in here? 3 times 4. 3 times 4. 3 times 4, and that is 12. Next one. When x was negative 1, what was f of x squared? Positive 1, so it's 1 times, again, why am I starting with 1? It's 3 times 1. 3 times 1, and that is 3. The next one would be 3 times what, everyone? 0, and that's 0. The next one is 3 times 1, and that is 3. The next one is 3 times 4, and that is 12. And the last one is 3 times 9, that's 27. And let's plot that. Here it goes. Negative 3, 27. Do we have 27 numbers on the graph? No, that doesn't fit, so let's go to the next one. Negative 2, 12. Negative 2, 12. Negative 1, 3. 0, 0. 1, 3. 2, 12. 3, 27, somewhere over there. So I'm just going to do this and put arrows like coming off the grid like so, and we're going to label that g of x. All right. So let's make an observation. Look at it. Something happened to my original 1, 2, 3, 4, 5, 6, 7 points. So here 0, 0 stays the same. Look at these 2 points right here. They came right there. These 2 points, they are right here. And these 2 points are way off the graph. So think about it. Let's say you're a little person in your life, the one that wants your Takis and your flaming hot Cheetos, or they want your gaming stuff when you're on it. They come in and you tell them, well, if I take this one what would you tell them happens to get the green one without showing them the numbers? Tell your neighbor. Talk it over to your neighbor. What do you think happens to that black one to get the green one? What would be a word that you would tell them? To get from the black one to the green one, what happens? I heard stretch. That is correct. So I want you to write the word stretch. Stretch. Now check this out. What was the parameter that we stretched it by? By what? 3. Let's see if it's true. Writing utensils down, look up to the screen. I'm going to zoom in. Here it goes. Watch. Look up, you're going to miss it. The original was at 0, 0, yes? Stays at 0, 0. These 2 points are at negative 1, 1 and 1, 1. But now they became what? Negative 1, what? 3 and 1, 3. Because the parameter was what? 3. Let me go to the next points. These 2 points are negative 2, 4 and 2, 4. What did the new points become? Negative 2 what? 12 and 2, 12. And they were at what? At 4. And now they became what? 12. They were at 4 and they went to 12 because the parameter was what? Times 3. Next, these 2 points, they are at, what is the y value here for these 2 points? 9. And what are the points that are completely off the grid? They are at what? 27 because it's by 3. All right. So question. Look up. If this is a 3, which is a whole number, stretches the original f of x to give us g of x, what do you think is going to happen? Instead of a whole number, it's a fraction. Talk it over your neighbor. What do you think would happen to the original black one if it's a fraction as the parameter that multiplies? What would happen? So the green one stretches. The red one would do what? Let's see. Let's pass it to, well, it hasn't gone in a while. Geo. What happens with the red one? Geo. It gets smaller or it shrinks. Let's see if it's true. Look up, please. So, let's try it. We got 1/3 times, what was the original f of x squared? It was 9. So let me zoom in. Let me use a smaller font. 1/3 times 9 is the same as 9/3, which is 3. Are we there so far? Next one. 1/3 times, what was the original f of x squared? Let me see. The original was a 4. So, times 4 becomes 4/3. I'm going to use decimals. Is that okay with you guys? Theo says no, but tough. Life is tough. We're going to use decimals. 1 1/3 or 1.3. Next, 1/3 times, the original was a 1, so therefore this stays 1/3, or in decimal form, 0.3. Was it 2? Oh, my bad. Let's see. -1, 1. Are you trying to trick me, Gio? My goodness. 1/3 times 0 is 0. Next, 1/3 times 1 is 1/3, or 0.3. Next one, 1/3 times 2 squared was 4 is 4 over 3, or 1.3. And last but not least, 1/3 times 9 is 9 over 3, which is 3. All right, let's graph that. I'm going to leave it zoomed in so you guys can see where I'm placing the points. Here it goes. -3, 3. -3, 3. -2, 1.3. -2, 1.3 is about right there. -1.3. -1.3. 0, 0. And then the other side just reflects these points. Is that correct? All right, right here, and right here. Label that G of X. Let me zoom out. And according to Geo, he said that it was going to what? What was the word he used? Shrink, yes? All right. So, stretch. This one, we can write the word a little bit more proper. Compress. It compresses to a smaller graph. Compress. So, what can we conclude if we have a number multiplying in front of the function? If it's a whole number, it's going to do what? Stretch it. If it's a fraction, it's going to compress it. Does that make sense? Yes? All right. So, from 1 to 5, I'll come to where you understanding this part? Yeah. And once again, I hope, my hopes are that you already saw this last year towards the end of the school year. Right? Good. But if not, I'm doing tic-tac-toe so you guys can get it before we move on to more stuff. So with that said, write this rule at the top of your page, please, on that graph paper. Our new rule, G of X equals A times F of X minus H plus K. Write that in there, please, at the top of your graph paper, way at the top. Kind of like a title, make it big. G of X equals A times F of X minus H plus K. So just to remind everyone, what does K do to the entire function? Victoria. Up and down. Up if it's positive, down if it's negative. Write that in there, please. Next, H goes what, everyone? Side to side. It goes to the right if we substitute a positive value. It goes to the left if we substitute a negative value. With green, I'm going to circle the letter A, and I'm going to write, it does two things. What does it do? It stretches, if it's a what? A whole number, that is correct. Or it compresses, if it's a fraction or decimal. All right, so far so good. How we doing? From 1 to 5, I'll come through you with the 3 parameters so far. Okay, we're getting there. We're getting there. We just need practice. All right, so with that said, get a new graph paper, a big one, another big one. Copy this at the top left, example 1Q, example 1Q. Copy that one. It says graph f of x equals x squared, then transform given g of x equals 3 parentheses x minus 5 close parentheses squared plus 2. Copy that. So, as Maria was asking, Mr. Q, what domain do we use? So let me ask you a question. Yesterday I said, to graph this without a table, where do I start? Remind your neighbor, where do we start to graph that one without a table? Talk to your neighbor, where do we start? Where do we start? Here it goes. I'm going to highlight it so you guys can remember. Look up to the screen. We start by looking at -2. What is -2 squared? +4. So we start with -2, 4. That's exactly how the home plate is going to go. -2 squared is 4. What is the next x value to the right? -1. What is -1 squared? +1. What is 0 squared? 0. What is 1 squared? 1. What is 2 squared? 4. And that's the domain that I want you to use from this point forward. Once again, if it doesn't say what domain, that's the domain that we're going to use from -2 to 2. Label this one f of x. Are we there so far? All right, next. Look up to the screen. I'm going to pause the music. Tell your neighbor where we're going to move these 5 points according to H and K. Where are we moving those 5 points according to H and K? Tell your neighbor, please. Where are we moving those according to H and K? According to H and K, we haven't called on Natalia Castro. Where do we move them according to H and K, Natalia? She said 5 to the right, okay, and then 2 up. So label that. Don't move them yet because we have to do something before we move them. All right. So we know where we're moving at the end, yes? But what do we notice now that we have a what? A multiplier. So that means this point, I'm going to start with this one. Look up. -2, 4. Instead of -2, 4, now it's going to be -2 what? 3 times 4. -2, the output was 4, but we're going to multiply that times 3, so that gives us -2 what? All the way to 12. Put that with your pencil. Use your pencil for that one. Here it is. I'm going to use a gray because that's not the final transformation. Once again, how do we get there, Mr. Q? Well, look, -2, 4 was the original. But since we're multiplying times 3, so now it's -2 instead of 4. 4 times 3 is 12. Next one. -1, 1 is the original, but since we multiply times 3 is -1 what? 3. That is correct. Plot your point at 3. 0, 0, multiply times 3 is still what? 0. The original was 1, 1, but since we multiply times 3, it's 1, 3. Next one. The original is 2, 4, but instead of 2, 4, since we multiply times 3, it's 2. 4 times 3 is 12. Don't graph your curve, but those are my new 5 points. Now, do we know where to move those 2 now? Yes, we're going to move them what? 5 to the left, 5 to the right, and 2 up. So I'm going to start with these on the top. 1, 2, 3, 4, 5, 2 up. This one, 1, 2, 3, 4, 5, 2 up. These 2 right here, 1, 2, 3, 4, 5, 2 up. This one, 1, 2, 3, 4, 5, 2 up. And the vertex. 1, 2, 3, 4, 5, 2 up. And now we connect those points. And we label it g of x. So question, did we move it to the right and up? Yes, but before that, what did we do? We stretched it because it was a multiplier of 3. All right, let me send you a screen so you can send me your graph. I want to see your transformation. Second. Send that in, please. From 1 to 5, how are we with these so far? Where are we at? 3s, 4s, 5s, 3, 4, 5. Okay. Let's do another one. Get a new graph paper, another big one. Right? Example 1, super Q. And it says graph f of x equals x squared. And now we're going to transform according to this red one, which is g of x equals 2 parentheses x plus 3 squared minus 7. And for the sake of time, I'm going to have Scarlett get us started. Before she does, tell your neighbor where do we start to graph this one without a table? Where do we start to graph this one without a table? Without a table. It's just what we just did. All right, Scarlett, where do I start? Negative 2 becomes? Negative 2 becomes 4, yes? Negative 1 squared is 1, 0 squared, 1 squared, and 2 squared is 4. All right, so we got our f of x. Oh. All right, so according to the red transformation, tell your neighbor where we're moving it to in regards to h and k. Where are we moving it to in regards to h and k? Got someone, Scarlett? Julian. To the left 3 times and down 7. So we got that down. However, we need to do what first, everyone? The multiplier. So I'm going to use gray. I'm going to start with 2, 4. Instead of negative 2, 4, now it's multiplying times 2 is negative 2 what? Instead of 4, it's what? 8. Negative 2, 8. Next one. Negative 1, 1. That becomes what, Leo? Negative 1, 2. That is correct. 0, 0 stays 0. 1, 1 becomes 1 times 1 is 2. And 2, 4 becomes 2, 8. And now we have our new point, and now we're going to move them what? 3 to the left and 7 down. So I'm going to start at the top. 3 to the left, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. This one, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. This one, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. There's the other one next to it, and one down here. And we label that g of x. From 1 to 5, I'll come through you with this one. Where are we at? Yeah, 4, 5, 4, 5. We just need practice tonight, yeah? We'll stop right there. Those of you following on YouTube, make sure you get some practice in. I'll see you guys next time. Peace.